Hello, welcome to Reasoning and Geometry. We're going to just talk about a little bit of logic stuff and kind of continuing our conditional statements into things, kind of the background and the base we need to work with proofs. So that's why in this first slide you see, why do lawyers have to be good at math? Which is true. Lawyers are required to take calculus in college and all kinds of different math. Just because they know, colleges and universities know that logic comes from mathematics and comes from this. You can get being able to kind of lay things out in an organized, clear fashion to say yes, they're guilty or no, they're not. Is a skill you got to have to be especially if you're a trial lawyer, right? And any other type of lawyer, really. So that's just kind of one thing. There's a lot of professions like that. Like even like to be a politician or something, you kind of want to have all that kind of thing. If you want to be a good debater, you got to be able to logically kind of piece things together for people to persuade them the right way. I know that like Euclid wrote a book called Euclid's Elements, which is still out there, and people buy it and read it all the time. Not necessarily for the math, but because of the logic, the step-by-step logic that President Lincoln back in the day, he read Euclid's Elements. Ronald Reagan, he read Euclid's Elements just because they wanted to be more logical and they wanted to be able to piece things together in such a way that somebody else can't deny the truth. They can't deny what you're putting in front of them. So it made them a better debater and it made them a better lawyer. Anyway, let's get to it. So there's a couple things. Just it should be short notes today, I hope. But deductive reasoning is something we've gone over already. This is the whole basis of Euclidean geometry, is deductive reasoning. It's based on facts, so you're using previously shown and proven facts put together to prove a new fact. And then you take that fact, add it on, and make another fact and another fact. So Euclid started with point, line, and plane, just three basic assumptions, put those together to create circles and segments and lines. And then it goes into parallel lines, which we're going to see. We're going to take parallel lines and transversals and quadrilaterals, and we're going to put all that into similar triangles and congruent triangles, which leads into trigonometry, sine, cosine, tangent. It all comes from these basic three ideas of point, line, and plane. The rest all comes from proofs, like just to build a skyscraper or anything you see around you, all the man-made stuff you see wouldn't be uh, readily available. It would have been a little harder to deal with and kind of work with if we didn't have geometry, right? And Euclid went and done his thing. So anyway, deductive reasoning is based on fact, and that's what we're doing here. Now, if you're taking AP statistics or statistics class, that's going to be based on inductive reasoning, based on patterns. We don't always know the real truth in statistics, so we follow patterns and try to make assumptions about what we think is going to be true. We collect like a sample from a population, and whatever's happening in the sample, we just assume to be true in the whole big picture of the whole population. That's inductive reasoning. We don't know the facts. In Euclidean geometry, it's deductive reasoning. It's facts based on facts. Now, there's always some assumptions, but it's fact based on facts. So let's take a look at this example. Andrea knows that Todd is older than Chan. Okay, Todd's older than Chan. She also knows that Chan is older than Robin. So if Todd's older than Chan and Chan's older than Robin, then she knows, like deductively, that Todd has to be older than Robin. I mean, it makes sense, right? So that's deductive reasoning. It's facts. There's no way around it. Okay, here's a different one. Andrea knows that Robin is a sophomore and Todd is a junior. All the other juniors, Andrea knows, are older than Robin. Therefore, Andrea reasons inductively that Todd is older than Robin. Just because he's a junior doesn't mean he's older, right? I mean, you would think maybe, but you never know for sure, right? It's possible that Robin, even though they're a sophomore, is older, and Todd, that even though he's a junior, is younger, right? So that's possible. So this is just inductive reasoning. Following a pattern, making a conjecture based on what you see in front of you. Okay, so it's important to know those really well. It's kind of the whole basis of things, right? Let me move this out of the way. Okay, law of detachment. We got two things. It's really two basic ideas. We got law of detachment and then something called law of syllogism, what we're going to look at. These are the new things. So law of detachment. This is the whole basis of why we can use deductive reasoning. First, you have to start with with a statement that is true, and you know it to be true. Like right here. So if you leave a problem blank on the test, you will not get an A. So let's say you have a 10-point test or an 8-point test or something, and you leave one of them blank, then if it's a fact that you're not going to get an A on that test, right? So this is the original statement, the thing that we know to be true. Like there's just no other way around it. So if we know something is true, like we have a true statement, then we can apply it to situations we run across, all situations. I remember in other videos I talked about how a statement works for everything. If there's one thing it doesn't work for, it's not a true statement anymore, because you found a counterexample, and then that statement's no good. So this has to work for all situations. So the law of detachment just basically just says what is logical and makes sense, that you can use it for any other situation then, because if it's a true statement, it works for everything. So if we have Tammy left number 7 blank on her test, what can we conclude? Well, we can conclude that she's not going to get an A. I don't know what she's going to get because I don't know what the rest of her questions are, but the statement says she won't get an A. So I know if she leaves 7 blank, she's not going to get an A. It's a fact. There's no way around it. All right. So law of detachment says you can apply a general statement to something specific you run across. Okay, here's another example. If two angles are supplementary, then their measures add up to 180 degrees. We've seen this before. Supplementary means 180 degrees. So this is a fact. There's no way around it. If two angles are supplementary, they add up to 180 degrees. All right, so now this is a specific example of this, and we can use this statement to apply it to this specific example. So if we have these two angles, CDF and PWQ, if we know they're supplementary, right, and this probably should have an if and then. Whoops, that's weird notation. But if we know they're supplementary, then we can conclude, like this part doesn't even have to be here. That could be gone. Because I know this original statement is true, then I know that they have to add up to 180 degrees. That's our conclusion that we can get from this original statement, whether it's written for us or not. We know it. Okay, we'll practice a couple of these in class. That's just a little warm up for the next one. So penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows, right? That's not good logic, but why? What's wrong with that? There is a problem with that one, right? I gotta get this out of the way. Maybe up here is better. Like, what's the problem with that? Well, the problem with this is the penguin tried to use the converse. They said penguins are black and white. They said TV shows are black and white. So if it was the reverse, where everything black and white was a TV show, then you'd have a connecting thing, right? But they're trying to use the converse, which isn't true, right? So they're using the converse. The original statement is true. Old TV shows are black and white, but the converse is not. Just because it's black and white doesn't mean it's a TV set, because it could be a penguin or it could be something else, right? So they're putting that together. But this also is trying to warm you up. They're trying to connect statements together, which is what we call the law of syllogism. So the law of syllogism is connecting statements together. So if P, then Q, and if P is true, then Q is true, if we know that to be true. And then we know Q is true, then that means R is true. That's another statement. Then we can connect them. This one's pretty easy to understand when you see an example here. So if Joe lifts weights, then he'll get stronger. If he gets stronger, then he'll become a better wrestler. So then you can conclude that if Joe lifts weights, then we can conclude that, well, yeah, he'll get stronger, but he'll become a better wrestler. So the middle part we leave out, right? This connecting piece we'll just leave out, and we'll go right to the end. So if Joe lifts weights, then he'll become a better wrestler. The middle part just becomes the connecting piece that you can drop out and make a new conclusion. And that's the power of this. You can make new conclusions that you didn't know was true to begin with, but because you went through the connections, you can come up with something new. So if you study hard, then you'll get a good grade in geometry. If you get a good grade in geometry, then your parents will be happy. If your parents are happy, then they will buy you something cool. Excuse me. If they buy you something cool, then you will study even harder. And if you study even harder, then you'll go on to be really smart. And if you're really smart, then you'll get good grades in college. And if you get good grades in college, then you'll get a good job. And if you get a good job, then you'll make lots of money. And so, like if I put all that together, then the conclusion is I forgot where I started, but if you study hard in geometry, then you'll make lots of money, right? Kind of thing. So you can connect things and as many as you want. But the thing about these is each statement themselves have to be true to begin with before you can connect them together. If even one of those statements is false, you can't put them together. So here's a geometrical example of that. So if an angle measures between 90 and 180, then we know it's obtuse. That's how we define it. We know that's a true statement. So if an angle is obtuse, then it is not acute. Well, we know that too. It can't be both. All right, so then we apply it to this. So the measure of angle ADH is 110. We can conclude that it is not acute. So we're kind of doing syllogism and law of detachment at the same time. We're applying it to a specific situation, but we're also putting two statements together. We're using the first statement to say it's obtuse, and then the second statement to say, well, yeah, I know that if it's obtuse, it's not acute. So we're putting that together. So if it's 110 degrees, it's not acute. We can kind of put that all together. So we'll practice more of this in class, but this is one more that we can try to put together. So all these statements are assumed to be true. So let's put them together. If you do not make friends, you will not be lonely. If you cheat on a test, then you will feel bad about yourself. If you are sad, then you will not make friends. If you study hard enough, you will not get an A. And if you feel bad about yourself, then you will be sad. We're trying to put these together. So the then part of one statement needs to match the if part of another statement. So cheat on a test, you'll feel bad about yourself. Oh, so if you feel bad about yourself, here, and if you feel bad about yourself there, you'll feel sad. If you study hard enough, you'll get an A in the test. I'm noticing that this statement right here doesn't really connect with anything. So if you study hard, I don't see anything about studying hard. You will get an A in a test. I don't see anything that says getting an A in a test. So this is an extra statement that we really can't use to connect to anything. I do see this other stuff though, like feeling bad about yourself here, but that's already being used up here. So let's go through it. I would start right here if you cheat on a test. All right, let me get a pen, I think will be better. Grab a red pen. Okay, so we're going to start with if you cheat on a test, then you will feel bad about yourself. So I'm looking for where it says if you feel bad about yourself, which is down here. If you feel bad about yourself, then you'll be sad. So we're going to go to that one next. If you feel sad, I'm looking for that. Here it is. So if I feel sad, then you will not make friends. And then I see up here, if you do not make friends, then you'll be lonely. And then this one doesn't connect with anything. So then you'll be lonely. So I started with if you cheat on a test, and we go through all that stuff to connect it. And final conclusion is then you'll be lonely. So that's if all these statements are true, again, they all have to be true. But if these are all true, then I can conclude if you cheat on a test, then you'll be lonely. Now, of course, you can argue that one of these is true or not true or whatever. But so don't cheat on your test because then you'll be lonely. All right, that's it for now. We will practice some more in class. Thank you very much.